Okay, third assessment for properties and exponents. You know what that means. That's the final one, okay? 6 to the third, that's easy. 6 times 6 times 6 is 216. Not hard to figure out. Negative 5 times negative 5 times negative 5 times negative 5. The product's positive, okay, because you have an even amount of negative factors. 625, okay? Okay, negative 5 to the third. That's an odd amount, so it's going to be negative, and then it's 125. Now, fraction to a power, you just multiply 3/8 times 3/8 times 3/8, and the top multiplies to a product of 27. 8 times 8 is 64, times 8 is 512. Okay, easy enough there. Now, I want you to look through this page, and you tell me, are there any addition or subtraction operators? Nope, there's not, so no rainbows, okay? You need to make your 3 lines on all these and analyze what the problem is. Okay, now underline it if it's not there. So you have a base of 5 and a variable base of m. Don't repeat the m, just once. So 5 is to the 1, but there's a parenthesis surrounding it, so 2 times 1 is 2. Now there are 2 m's, but they're both on top, both on the same side, so that's just addition. So 6 times 2 is 12, plus the 3. Don't multiply 3, it ain't in parentheses, and that's 15. Now both the powers were 15 and 2. Those are positives, so they stay in the same place. So 5 to the second is 25, m to the 15th. You don't need anything on bottom. It's when the top's empty where you put a 1. Okay, my next one, underline, we got a base of 5 and a base of x. So to the first, but there's a parenthesis around it, so we distribute negative 3 to 1. That's negative 3. Negative 3 to 1, negative 3. Both those are negative. They then move to the bottom so that those 3's become positive. You need a top. You always need a numerator, so use a 1. I want to see that 1. So 5 to the third, well, I can take 5 times 5 times 5 on a calculator. I can go 5 power 3, and that's 125. And then the x to the third stays. I need the 1 on top, though. Don't need it on bottom, need it on top. Okay, now extend your line so you have numerical bases 2 and 3 and a variable of x, okay? Now on bottom you got an x, but I already have x on top. But I have a y on bottom, I don't have it on top, so you put y on the bottom, and it's, okay? So, 2. And that's surrounded by parentheses. 3 times 1 is 3. 3 to the 1, surrounded by parentheses. 4 times 1 is 4. Now, how many x's you got? You got 2, and they're on different sides of the line. So we need to set up our minus, okay? So top minus bottom. So what x do I have on the top? Right here. It's 4, but I got to take it times 4, and that's 16. Now, I don't add to it because that's the only x I have on top. Now, on bottom, I have this x to the second, but that's in parentheses, so I take 3 times 2, and that's 6. 16 minus 6 is 10, okay? Then y, this is the only y. 2 times 4 is 8. Don't move any of these. They're all positive powers. And keep the dang y on the bottom. Don't move it to the top. You have no reason to move that to the top. It's positive. Okay, so 2 to the third. That's 2 times 2 times 2. Last time I checked, that's, whoops. That's 8. So replace that with 8. 3 to the fourth is 81. And then we keep the x to the 10th, and we keep the y to the 8th, but it stays on the bottom. Don't put it on top. Okay, so 8 times 81, because you can multiply that. That's 648. So there's my simplified expression. Beautiful. Okay, now my next one. Top, we got a 2 and a variable e and a variable g. Now on bottom I just have repeats of stuff I already have on top. Okay, so we start off with nothing on bottom. So 2's to the 1, but I need to take 1 times negative 4. That's negative 4. Now e, how many e's you got? You got 2. They're on opposite sides, so that's minus. Okay, so top minus bottom. This is the only e I have on top. 1 times negative 4 is negative 4. There's no more e's on top, so I don't add to the negative 4. Now bottom. Bottom we have to the 5th, and not the parentheses is not around that, so I use 5. Okay. So negative 4 minus 5. Think of a number line. Okay. When you subtract, you go this way. Negative 5, negative 6, negative 7, negative 8, negative 9. So it's a negative 9. Okay. Now G, you got 2 G's. Again, top and bottom. So that's a subtraction. I like to really think about my subtractions. Okay, G to the 5th, no parentheses, so 5. We're not going to add because that's the only G I have on top. And then I have negative 3. Now if I'm subtracting a negative, I make that addition of 3. So 5 plus 3 is 8. Okay, 2 moves to the bottom, so its 4 becomes positive. Same with the E, the 9 becomes positive, but the G has no reason to move. It stays in the side it's on, so G to the 8th. 2 to the 4th, I figure that out, that's 16. Times E to the 9th. Okay, see how all that makes it smooth? Okay. All right, graphing an exponential function. Sorry, you can't read it. It's negative 3 times 1/4 to the x power. Put a little power symbol there. Exponential functions, okay? Exponential functions, you make a table and you go 2, 1, 0, negative 1, negative 2. Okay. So first, I just punch that into the calculator. Okay. So I go 1 over 4, parentheses, and then raise it to the power of 2. That's going to be 1 over 16 because 1/4 times 1/4 is 1 over 16. Now that also tells you what the negative exponent would be, a negative second power. That would be 16 over 1, but I don't need the 1. It's just 16. 1/4 to the power of 1 is 1/4. So this would be 4 over 1, but I don't need the 1 on the bottom. It's just 4. Anything to the 0 power is 1. Okay? Now take all these times negative 3. Okay? So that's going to be negative 3 over 16. I'm just showing you how to get it. Negative 3 times 1 over 16 for some of you fraction phobes. Now that's less than 1 whole. Okay. Okay, then I take negative 3 times 1 over 4. Negative 3/4. That's negative 3. That's negative 12 and negative 48. Okay. Now, here's how you graph them. These are your outputs. So 2, negative 3/16. By the way, to get to 48, you're going to have to go by tens. Okay. Or actually, 5s will work, I think. Okay. So 2 guys, you go right to negative is down. 3 over 16 is just really close to the line. Okay, that's all that is. It's less than 1 whole. Okay, then 1 negative 3/4. Negative 3/4 is really close to the line. A little bit further down. 0, negative 3. Now I'm going by 5s, remember, so negative 3 is about here. Okay. 1, negative 12. Negative 1, negative 12. So left 1, down 5, 10, then 12. Negative 2, negative 48. Left 2, 5, 10, 15, 20, 25, 30, 35, 40, just 48 down there. Now, it's impossible for this to ever make it above the the positive. It will never get into the positive, so don't cross the middle line. You just go close to it, okay? Okay, and then the story problem. A recent college graduate accepts a job at a law firm. The job has a salary of $32,000 per year. The law firm guarantees a yearly pay increase of 3% of the employee's salary. Find the employee's salary after 5 years. I'm going to change the way I explain this so it gets dollars and years are your units. Okay, that should say dollars down there. So X is years, Y is dollars. So dollars per year. Well, the problem is it doesn't exist. It's a percentage per year, and it's 3%. So plus 3% because it's increased. So I need to take 100% plus 3%, which is 103%, which is 1.03. So we know percents and is repeated multiplication, not addition, so it's a curve. Now don't label that curve, okay? All you need to write is blank times blank to the power of x equals blank. Now where's your money start at? Money starts at $32,000. Now this is my percentage, and it's 1.03. X is the years. Well, I know how many years I have. It's 5, okay? I don't know what my money ends up at, so that's Y. Just punch it in on the calculator. 32,000 times 1.03 to the power of 5, $3,097, or $37,097. So again, blank times blank to the power of X equals blank, okay? I mean, if you really want to, you got your B, which is your beginning Y, 32,000. And from there, it's times G to the power of X. You know your G is 1.03. And then Y. So 32,000 times 1.03 to the power of X equals Y. I know my X is 5. Bam.